where A, B, C are the constant, why 3 constant? Because you are having here cubic equation. Now you got the values of A and B. Now substituting in the what we have? A splitted, a partial fraction. Degree of the numerator is equal to or degree of the numerator is greater than degree of the denominator, then it is called improper partial fraction. Hello dear students, a warm welcome to one and all. My name is Vibha, Mathematics faculty at Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. So in the last session, we have learned many problems on some particular integrals. And in today's session, dear students, here we are having session number 11 and a chapter number 7 which is called integrals. And what are the topics we are going to study under this session is nothing but you are going to have integration by partial fractions. Then we'll be moving on to what do you mean by that partial fraction, how you are going to have a terms of those partial fraction as a problems. Now we'll be moving on to here, the table has given a form, a rational function, a form of a partial fraction. They will be given in the form of a rational. You are going to convert that rational in the form of a partial fraction. Now here, if they have given in the form of px plus q divided by x minus a into x minus b, where a not equal to b, if a equal to b here, you are going to get a quadratic equation. Here you are going to have a divided by x minus a plus b divided by x minus b. Okay. So therefore, you are going to write if it is in this form, a partial fraction as like this. Remember dear students. And then second form, if it is in the form of px plus q divided by denominator x minus a whole squared. So that only here they have given the condition a not equal to b. If a equal to b, it will come to this form, x minus a whole squared. In that, how to write the partial fraction? You can write a divided by x minus a plus b divided by x minus a whole squared, where a and b are the constant, dear students. Why? Because here you are having, if you multiply, you are going to get it as degree 2. Degree 2 means 2 constants you are going to introduce. Here also you are having degree 2. Degree 2 means 2 constants you are going to introduce. Understood? So, and then if numerator it is in the form of a quadratic equation and denominator if it is in the form of a cubic equation, that means you are having x minus a into x minus b into x minus c. Then you are going to write a divided by x minus b, a divided by x minus a plus b divided by x minus b plus c divided by x minus c, where a, b, c are the constant. Why 3 constant? Because you are having here cubic equation. So therefore, you are going to write accordingly the partial fraction and then finding the values of a, b, c and then substitute back to the integration and then moving on to finding the integration of that problem. I hope you got this one. Please do remember all this. We'll be moving on to the next type. If it is in the form of numerator px squared plus qx plus r, it is in the quadratic equation, and denominator x minus a whole squared into x minus b, then you are going to write, so a divided by x minus a plus b divided by x minus a whole squared plus c divided by x minus b. So here also in the denominator you are having cubic, so therefore 3 constant you are going to introduce and writing the partial fraction like that. And then we'll be moving on to the fifth type. They have given quadratic equation will be in the numerator, which is of the form px squared plus qx plus r divided by in the denominator x minus a into x squared plus bx plus c. Then you are going to introduce accordingly the partial fraction. You are going to write it as a divided by x minus a plus bx plus c divided by x squared plus bx plus c. Like this you are going to write it as. So all this you have to remember to solve the problems of the partial fractions, dear. And here further, where x squared plus bx plus b cannot be factorized further, there you are going to write as it is. Understood? So now we'll be moving on to remembering all this partial fraction conversion of problems. What they've asked, the first problem, find integral of dx divided by x plus 1 divided by x plus 2. See, numerator it is in the form of px plus q. So where only q is there, x coefficient you do not have, which is nothing but 1 you can consider. So which is in the form of that dx divided by x plus 1 divided into x plus 2, which is in the form of 1 divided by x plus a into x plus b, which can be written as, so I am taking that one 1 over x plus 1 into x plus 2 can be written as a divided by x plus 1, because denominator we are having a quadratic equation which is a degree 2, so I have to introduce two constants here, plus b divided by x plus 2 according to the first form what I have given the table I am writing here. And then you need to find out now a and b value. So how to find out now a and b value, dear students? See what you are having in the left hand side, denominator multiply throughout. So I am going to multiply throughout by x plus 1 into x plus 2. Now if you multiply x plus 1, x plus 1, x plus 2 will get cancelled. Remaining in the left hand side is 1, which will be is equal to x plus 1 will go. Remaining is a into x plus 2, a into x plus 2 plus b, x plus 2 will get cancelled, b into x plus 1. Okay, so multiplying throughout that. Are you getting this one? Now here you are going to multiply whatever it is there in the right hand side, a into x plus 2a plus b into x plus b. Now you can take x common factor here, which will become a plus b into x plus 2a plus b. Now what you are going to do? You are going to compare the coefficient of the x and the constant term. Now let me compare the coefficient of x and constant term. Comparing coefficient of x and constant terms. Okay. So what happens in this case? Now first let us look into the coefficient of x in the right hand side. Right hand side you are having coefficient of x is nothing but a plus b. Therefore a plus b will be is equal to, see here the left hand side no x term you are having, only 1 which is a constant, not the coefficient of x. So therefore in the left hand side it is 0. So I am equating a plus b equal to 0. Now let us look onto the constant term. Constant term in the right hand side is 2a plus b. In the left hand side you are having 1. So therefore I can equate 2a plus b is equal to 1. Isn't it? Otherwise I can have here b will be is equal to 1 minus 2a. So therefore I can substitute here b will be is equal to 1 minus 2a. So b is 1 minus 2a will be equal to 0. Otherwise you can have a minus 2a which will be is equal to minus a plus 1 equal to 0. Otherwise taking a to that side, a will become 1. If a is 1, you can now find out what is b. Now here you are having b will be is equal to 1 minus 2 into 1, which will become b is 1 minus 2. Therefore which implies b is equal to minus 1. Otherwise you can equate here only a plus b is equal to 0, b is equal to minus a. So which will become minus 1. That's it, dears. Now you got the values of a and b. Now substituting in the what we have, a splitted, a partial fraction. Therefore I can have integral of 1 over x plus 1 into x plus 2 into dx, which is equal to integral of a divided by x plus 1 into dx. I am segregating this one, dears, plus integral of b divided by x plus 2 into dx. I hope you got this one. Now which implies, now substituting the a value and b value, a divided by, that is a value is 1. So 1 divided by x plus 1 into dx. Again b value substituting, you are having minus 1, plus into minus it will be a minus only, minus 1 divided by x plus 2 into dx. I hope you understood this one. Now what is this? 1 divided by x plus 1, integral of, which is log of modulus of x, which can be log of modulus of x plus 1 divided by 1, because coefficient of x, again minus log of modulus of x plus 2, coefficient of x is 1. Now anything divided by 1 will be the same, you are going to get it as, now this is in the form of log m minus log n, which can be written it as, which implies log m by n, which is log of modulus of x plus 1 divided by x plus 2 plus c. And this is your final answer, you are going to get it as, dear students. I hope you understood this one, how to solve the problems by partial fractions. Now we'll be moving on to the next problem. What they've asked, integral x squared plus 1 divided by x squared minus 5x plus 6 into dx. Dear students, you cannot see in the table which both numerator and denominator of the same degree. Now you are having, see here also degree 2 you are going to have in both numerator and denominator. If numerator degree is equal to the denominator degree or numerator degree is greater than denominator degree, then it is going to be known as improper partial fraction. So therefore, we need to reduce that improper partial fraction to a partial fraction by dividing. How we are going to divide? Divide the numerator by denominator. Now let us do that one first. Dividing, since both numerator and denominator degree is same here, we are going to divide the numerator by denominator. Divide the numerator by denominator, x squared minus 5x plus 6. Now here you can multiply this by 1, so it will be giving you x squared minus 5x plus 6. Now you can subtract this one, which will become, you can cancel x squared. So remaining here it is nothing but plus 5x minus 6 plus 1, which is nothing but minus 5. Then you can write this x squared plus improper partial fraction as proper partial fraction, which is nothing but this you are going to have dividend and then quotient and then remainder, right? Dividend, quotient and then remainder you are going to have. So this is D, you can have this is Q, you can have this is R, right? So you are going to write accordingly Q plus R divided by D. So you are going to write Q plus R divided by D, which is Q plus, that is 1 plus R by D, which is 5x minus 5 divided by x squared minus 5x plus 6. Okay, this is how you are going to write it as. Understood? Therefore, you can have, now if you multiply the same, you are going to get it as, why? Because I want to reduce the numerator degree to lesser than denominator degree, so that I am making by having a division method. So here you can write this one as, which will be integrating this integral of x squared plus 1 divided by x squared minus 5x plus 6 into dx, which is equal to integral of, I can segregate this 1 into dx plus integral of 5x minus 5 divided by x squared minus 5x plus 6 into dx. Now you know that integral of 1 into dx is nothing but x. Let me keep as it is. Now we need to find out this integral, isn't it? Now we need to find this integral, which is x we know already. Let me write it at last after integrating this one. So here you can have x squared minus 5x plus 6. This can be reduced to the form of by finding the factorization method. Now you can have, so I am writing here integral of 1 into dx as it is plus integral of, see you are having numerator is 5x minus 5 and denominator I am going to factorize. What is the denominator? You are having x squared minus 5x plus 6. If you multiply you should get 6. If you add you should get minus 5. Add or subtract. Now minus 3 into minus 2 is nothing but plus 6. Minus 3 minus 2 if you add minus 5 you are going to get. Therefore 3 and 2 are the factors. X squared minus 3x minus 2x plus 6. Otherwise, x into x minus 3, you can take x common factor, here minus 2 common factor, x minus 3, and then taking x minus 3 common factor, you are going to get it as x minus 2. Therefore, you can write x squared minus 5x plus 6 as x minus 3 into x minus 2. Writing it here, x minus 3 into x minus 2. Okay. Now, you can have here, which is in the form of this is nothing but you can have, which will be equal to integral of 1 into dx is nothing but x plus c1. Why? Because c1, another c, you are going to get it here, so that c1 plus c2 I can take it as c at last. So I am doing here integral of this one. Now this integration I have to do. Let me do it by taking how? You are going to write this one as c plus I. So now finding for I am taking what is that? 5x minus 5 divided by x minus 3 into x minus 2, which can be written as how? It is in the form of px plus q divided by x minus a into x minus b. I can write that one as a divided by x minus 3 plus b divided by x minus 2. Now multiplying throughout x minus 3 into x minus 2. What you are going to get it as, dears? In the left hand side, both it will get cancelled. Remaining is 5x minus 5. 5x minus 5, which will be is equal to a into x minus 3 will go, remaining is x minus 2 multiplied, plus b into x minus 2 will go, remaining is x minus 3 is multiplied. Now what you are going to do? You are going to compare the coefficient of x and the constant term. Now you are going to comparing coefficient of x and constant terms. Okay, constant terms. What happens to this condition? Now you can observe, dear students, here a into x plus b into x. X can be taken common factor a plus b, isn't it? So a plus b in the right hand side, and in the left hand side, coefficient of x is 5 here. So a plus b is equal to 5. Let me keep as it is. Now see the constant term. Constant terms here, minus 2 into a, again minus 3 into b. So minus 2a minus 3b, which will be the constant term. So minus 2a minus 3b will be is equal to, what you are going to have? Constant term here, minus 5. So minus 5. If you multiply throughout by minus sign, you are going to get it as 2a plus 3b is equal to 5. Now, let me call this one as first equation. From the first equation, you can substitute either for b or for a. b is equal to 5 minus a. If you have substitute b is equal to 5 minus a, 2a plus 3 into 5 minus a is equal to 5. Now, let me solve this one. 2a plus 3 5s are 15 minus 3a is equal to 5. Now 2a minus 3a, it will be giving you minus a. Now 15 you can take it to that side, it will become 5 minus 15. Otherwise minus a you can take it to that side, 5 you can take it to this side. So therefore it will become, you are going to have, so let me write it here, which will be, see, you can have 2a minus 3a, which is minus a. Minus a can be taken to that side, which will become plus a, which will be now 15. 5 can be taken to this side, 15 minus 5, which will become 10. So a is equal to 10 you got. Now if a is equal to 10, I can find out aram se b by the first equation. A plus b is equal to 5. Now b is equal to what? B is equal to 5 minus a. So which will be, b is equal to 5 minus 10, which is minus 5. So now you got b is equal to minus 5 and a is equal to 10. Now substituting back to the equation by integrating. Now let me do that here, which implies already you are having x plus c1 plus here I am going to integrate a divided by what it is, x minus 3 into dx plus integral of b divided by x minus 2 into dx. Now here I can have, which implies x plus c1, substituting back to a value is 10 divided by x minus 3 into dx. 10 can be taken outside, plus into minus, because b value is minus symbol. So plus into minus is minus, integral of 5 divided by x minus 2 into dx. Now since it is a constant, 10 can be taken outside, 5 can be taken outside. 1 divided by x minus 3 integration is log of modulus of x, which will be x plus c1 plus 10 into log of modulus of x minus 3 minus log of, that is 5 into modulus of x minus 2 plus c2. Now c1 plus c2 you can have, but what this will become, you can, this is n log m. What is n log m? Which will be log of m power n. So I can write this one as, which implies x plus c1 plus log of modulus of, that is x minus 3 to the power of 10 minus log of x minus 2 to the power of 5. Same equation I have applied. So which will become now log m minus log n, which is log m by n. So I can write this one as x plus log m by n, which is x minus 3 whole to the power of 10 divided by x minus 2 whole to the power of 5 plus c, where c is nothing but you are going to have c1 plus c2, and you can write this c1 plus c2 as nothing but c you can have. Okay. So therefore the answer you are going to get it as x plus log of x minus 3 whole to the power of 10 divided by x minus 2 whole to the power of 5 plus c. That is your final answer. I hope you understood this one. Now we'll be moving on to the next problem. What they have asked: find integral of 3x minus 2 divided by x plus 1 whole squared into x plus 3. Now this is in the form of px plus q divided by x minus a into x minus b whole squared into dx, isn't it? Which can be reduced to the partial fraction as, now write whatever the given in the inside the integral, 3x minus 2 divided by x plus 3 into x plus 1 whole squared can be written as a divided by x plus 3 plus b divided by x plus 1 plus c divided by x plus 1 whole squared, isn't it? Now because you are having in the denominator cubic means 3 constant must be introduced. Now here you can multiply throughout x plus 1 whole squared into x plus 3. Now what it will become? You can have 3x minus 2 is equal to a into x plus 3 is getting cancelled, remaining is x plus 1 whole square. Now plus b into one term of x plus 1 will be getting cancelled, remaining is one term of x plus 1 into x plus 3. You can see the whatever multiplication, plus c into x plus 1 whole squared, x plus 1 whole squared will get cancelled, c into x plus 3. And then now what you are going to do? Now here either you can substitute the value of x here or you can substitute the value of y. You are going to have, if x is equals to minus 1 plus 1 will get cancelled. Remaining is nothing but what? A 0. So one term will be eliminated. Here also two term will be, see, minus 1 plus 1 will get cancelled, isn't it? Therefore put x is equal to minus 1. X is equal to minus 1. So 3 into minus 1 minus 2 is equal to a into minus 1 plus 1 whole squared plus b into minus 1 plus 1 into minus 1 plus 3 plus c into minus 1 plus 3. Now you can have these two terms will go because it will come 0. Minus 1 plus 1 is 0. 0 into anything will be 0. So therefore this 2 will be 0. You can have in the left hand side 3 into minus 1 is minus 3 minus 2 which is minus 5, which will be equal to minus 3 plus 1 which is plus 2, 2c. Minus 5 is equal to 2c, or you can have c will be is equal to minus 5 by 2. Now you are getting c is equal to minus 5 by 2 means, now comparing the coefficient of x and the constant term. Let me see what happens. So comparing coefficient of, so you can have x squared terms, isn't it? And the x terms, okay? X squared and x and constant terms. So therefore now you can have, see here if you expand x squared you are going to get, here if you multiply x into x will be x squared. So a plus b will be the coefficient of x squared you can have. So therefore a plus b, so c will be not there, coefficient of x squared. So a plus b will be is equal to, coefficient of x squared in the left hand side is 0. So 0 I am writing. Now compare the coefficient of x. If you compare the coefficient of x is 3 here, let me write afterwards. Here another, see, x squared plus 2x plus a, correct? 2x means 2x a you are going to have. 2a will be the coefficient of x. So you can multiply here. What happens? 1 into x plus 3 into x. 1 into x plus 3 into x is nothing but 4x, isn't it? 4xb. So therefore 4b will be the constant. Again cx. So c will be the constant here. So therefore I can have here 2a plus 4b plus c is equal to, you can have here 3, coefficient of x, Therefore, now you can have the constant term. Constant term are nothing but already you have taken the value of C. C you can substitute here. A you can substitute as minus B. So, therefore, here A will be is equal to minus B. Substituting that, A will be as minus B. 2 into minus B plus 4B. Now, substituting the C value, taking to that side, 3 minus C, right? So, 2 into minus B is minus 2B. Minus 2B plus 4B is nothing but plus 2B. So, plus 2B is equal to 3 minus C value we got minus 5 by 2. Minus of minus it will become plus 5 by 2. So, 2 3s are 6. 2B will be is equal to 2 3s are 6. 6 plus 5 is nothing but 11 divided by 2. Now, you can cross multiply 2 here. So, B will be is equal to 11 divided by 4. Now, you got the B value as 11 divided by 4 and C value as minus 5 by 2. You can get A value aram se, which is nothing but minus 11 by 4 because negative of B is nothing but A. Now, all the values you got, A is minus 11 by 4, B is 11 by 4 and C is minus 5 by 2. Substituting here and then integrating. So, therefore, which implies integral of 3x minus 2 divided by x plus 3 into x plus 1 whole squared, which is nothing but integral of A divided by x plus 3. I have taken x plus 3 first, plus into dx, plus integral of B divided by x plus 1 into dx, plus integral of C divided by x plus 1 whole squared into dx. Now, substituting the value of A, B, C and taking outside. So, A value we know that minus 11 by 4 into integral of 1 divided by x plus 3 into dx, plus B value is only 11 by 4. 1 divided by x plus 1 into dx, and then C value you are going to get it as minus 5 by 2. Minus 5 by 2 into integral of 1 over x plus 1 whole squared into dx. I hope you understood this one. Now, here we are going to have minus 11 by 4 into log of modulus of x plus 3 divided by 1 because coefficient of x is 1 plus 11 by 4 into log of modulus of x plus 1 divided by 1 minus 5 by 2 into, if you integrate this one, integral of, it will be moving on to the numerator which is x plus 1 to the power of minus 2. X plus 1 to the power of minus 2 is nothing but x plus 1 to the power of minus 2 divided by minus 2 plus 1 divided by minus 2 plus 1 plus c. Because it is in the form of x power n. X power n integration is x to the power of n plus 1 divided by n plus 1, where n replaces here minus 2 whole over 1 because coefficient of x is nothing but here 1, which is the form of ax plus b. Now, here you can have, which implies, now you can take 11 by 4 common. So, 11 by 4 into log of, I am writing first positive, modulus of x plus 1 minus log of modulus of x plus 3, again minus 5 by 2. Here minus 2 plus 1 will be minus, minus into minus it will be plus. X to the power of minus 2 plus 1 is x plus 1 to the power of minus 2 plus 1 is x plus 1 to the power of minus 1, which will come to the denominator. So, therefore, you are getting 1 over x plus 1, okay, to the power of 1. If it goes to the numerator, you are going to get back to the same step. Minus 2 plus 1 is minus 1 plus c. Now, you can write this is in the form of what? 11 by 4 into log of modulus of x plus 1 divided by x plus 3 m by n plus 5 by 2 into 1 divided by x plus 1 plus c. And this is your final answer. You are going to get it as dear students. I hope you understood this one. Now, we'll be moving on to the next problem, dears. What they've asked. Integral of x squared divided by x squared plus 1 into x squared plus 4. So, how I can write this one as? I am going to substitute here. Let x squared is equal to y. So, if I am going to substitute x squared is equal to y, let me take that one. X squared will become y divided by, this is y plus 1 into y plus 4. Now, you can write this one as, which is in the form of ax plus b divided by x plus a into x plus b. So, a divided by y plus 1 plus b divided by y plus 4. Now you can multiply. After that, at last, let us substitute what is y is nothing but x squared. So multiply throughout by y plus 1 into y plus 4. So what happens to this condition? It will become y will be remaining in the left hand side, this 2 will get cancelled. Now y plus 1 will get cancelled, y plus 4 is multiplied, plus b, you are going to cancel with y plus 4, y plus 1 will be multiplied. Now you can either compare the coefficient of x, or you can substitute the y value as minus 1 here, so that you are going to get the a value, isn't it? Now put, because minus 1 plus 1 will get cancelled. Now put y is equal to minus 1. So minus 1, which will be is equal to a into minus 1 plus 4 plus b into minus 1 plus 1. So this will become 0. Now you can have minus 1 plus 4 is nothing but plus 3. Right hand side you are having minus 1. So minus 1 is equal to 3a, or you can have a will be is equal to minus 1 by 3. Now this is a value. Now you can take, let y is equal to minus 4, so that you are going to get b value. So therefore put y is equal to minus 4. So minus 4 in the left hand side, you can check over. Minus 4 in the left hand side. Here minus 4 plus 4 will get cancelled. So a into minus 4 plus 4 again plus b into minus 4 plus 1, isn't it? Now here this will become 0. Now minus 4 will be is equal to minus 4 plus 1 is minus 3b. Otherwise minus minus will get cancelled. B will be is equal to 4 by 3. Now b value you got 4 by 3, and a value you are getting it as minus 1 by 3. So what happens? Integral of x squared divided by x squared plus 1 into x squared plus 4 into dx is nothing but integral of a divided by x squared plus 1 into dx plus integral of b divided by x squared plus 4 into dx. Now substituting a and b value, you are going to get a value is nothing but minus 1 by 3, which is taken outside. Integral of 1 over x squared plus 1 into dx plus integral of b is nothing but 4 by 3. So 4 by 3 can be taken outside. 1 over x squared plus 4 into dx. Now dear students, this is also x squared plus a squared. So you know that integral of dx divided by x squared plus a squared is given by the formula 1 by a into tan inverse of x by a. So 1 by a into tan inverse of x by a. Here a replaces 1, here a replaces 2 squared, which is 2. Understood? So therefore writing accordingly, which will become implies minus 1 by 3 into 1 by a, 1 by 1 into tan inverse of x by a. X replaces x only, divided by a is 1. Again you are having plus 4 by 3 into 1 by a. A replaces here 2 squared, which is nothing but 2. So 1 by 2 into tan inverse of x by 2 plus c. And this is your answer you are going to get if you multiply. First writing the positive term. 2 ones are 2 twos are. You can have 2 by 3. 2 by 3 into tan inverse of x by 2 minus 1 by 3 into tan inverse of x by 1, which is x plus c. And this is your final answer. You are going to get it as. I hope you got this one. Now we'll be moving on to the next problem, dears. Integrate the following rational function. Here they have asked integral of x divided by x plus 1 into x plus 2 into dx. Now here same in the form of the first partial fraction, which I can write it as taking the integral of x plus 1, inner side of the integral x plus 1 into x plus 2, which can be written as a divided by x plus 1 plus b divided by x plus 2. Check out, dear students, numerator degree is lesser than denominator degree. Denominator degree is 2, numerator degree is 1. Therefore, it is a proper. I can multiply throughout by x plus 1 into x plus 2. So what happens to this? Here you can have x will be remaining, which is a into x plus 2. X plus 1 will get cancelled, plus b into x plus 2 will get cancelled, b into x plus 1. Understood? Now you can either substitute the x value as minus 1 and minus 2, or you can compare the coefficient of x and the constant term. Here I am substituting the x value. Put x is equal to -1. So therefore -1 is equal to, you can have a into -1 plus 2 plus b into -1 plus 1. Now this term will become 0. Therefore I can have -1 plus 2, which is plus 1, plus 1 into a is a only. A is equal to -1. So that is the value of a. Now you can have put x is equal to what? X is equal to, see what it will get cancelled? -2. So put x is equals to -2. So you can have -2 will be is equal to a into -2 plus 2 plus b into -2 plus 1. Now this will become 0. So -2 will be is equal to -2 plus 1 is nothing but -1. So -1 into b is -b. Minus minus will get cancelled. B will be is equal to 2. Now a value you got -1 and b value you are getting 2. Now taking here and integrating that. So therefore you can have, which implies integral of x divided by x plus 1 into x plus 2 into dx, which will become integral of a divided by x plus 1 into dx plus integral of b divided by x plus 2 into dx. Now you can take a outside by writing minus symbol, because a is equal to -1 there. So therefore integral of 1 divided by x plus 1 into dx plus b value you are having 2 into integral of 1 divided by x plus 2 into dx. Now you can aram se integrate this one. -1 over x is nothing but log of mod x. Here log of modulus of x plus 1 divided by 1, because coefficient of x is 1 there, plus 2 into log of modulus of x plus 2 plus c. Now you can have, if whole squared, see it is like n log m. N log m is log m power n. So therefore you can have minus log modulus of x plus 1 plus log, if you remove the modulus symbol, x plus 2 whole squared, okay, plus c. Now this is log m minus log n, which can be written as what? Which implies log of modulus of x plus 2 whole squared divided by x plus 1 plus c. That's it. I hope you got this problem also how to solve. Now we'll be moving on to the next problem. Integrate 1 divided by 1 over x squared minus 9 into dx. Now here you can think this one, which in the form of 1 divided by x squared minus 9, I can write it as 3 squared into dx, which is of the form integral of 1 over x squared minus a squared into dx, which is nothing but 1 divided by 2a into log of modulus of x minus a divided by x plus a plus c. This is of the form of the particular function. So now you can have a replaces here 3. Therefore, you can have integral of 1 over x squared minus 3 squared into dx is nothing but 1 divided by 2 into 3 into log of modulus of x minus 3 divided by x plus 3 plus c. Now you can write the answer as 1 divided by 6 into log of modulus of x minus 3 divided by x plus 3 plus c. That's it, dear students. Okay. I hope you understood this one also. Now we'll be moving on to the next problem, dears. What they've asked. Integral of 3x minus 1 divided by x minus 1 into x minus 2 into x minus 3. So therefore here numerator degree is lesser than the denominator degree. Denominator degree is cube 3, which is numerator degree is 1. Therefore 1 is lesser than 3. You can have writing 3x minus 1 divided by x minus 1 into x minus 2 into x minus 3, which is of the partial fraction px plus q divided by x minus a into x minus b into x minus c, which is a divided by x minus 1 plus b divided by x minus 2 plus c divided by x minus 3, because you are having a cubic equation in the denominator. 3 constant term will be introduced, multiply throughout whatever the denominator, x minus 1 into x minus 2 into x minus 3. Now what happens to this? Here you are getting these 3 will get cancelled, remaining is 3x minus 1, which is equal to a into x minus 1 will go, remaining is x minus 2 into x minus 3 plus b into x minus 2 will go, remaining is x minus 1 into x minus 3. Again, similarly, plus c into x minus 3 will go, remaining is c into x minus 1 into x minus 2. So I hope you got this one. Now, substituting the value of x there. If you substitute here plus 2, see plus 2. This will become 0, this also will become 0, then definitely you are going to get the b value. So, put x is equal to what? First I am going to get x is equal to 2. So, 3 into 2 minus 1 is equal to a into 2 minus 2 into 2 minus 3 plus b into 2 minus 1 into 2 minus 3 plus c into 2 minus 1 into 2 minus 2. Now, this term and this term will become 0 because 2 minus 2 is 0. Remaining only the b term. You can calculate here. 2 minus 1 is 1. 2 minus 3 is minus 1. Minus 1 into plus 1 is nothing but minus 1. Minus 1 into b is minus b. So here you can have 3 into 2 is 6. 6 minus 1 is equal to minus b. 6 minus 1 is nothing but 5, or you can have b will be is equal to minus 5, right? Because minus term will be taken to that side. So therefore b value you got. Now substituting, which will get cancelled. See, if you substitute x equal to 3, b and a will get cancelled, c will be remaining. So you will be getting the c value. So put x is equal to 3. Put x is equal to 3. So what you are getting in the left hand side? 3 into 3. 3 into 3 minus 1 is equal to, see, a term 3 minus 3 will get cancelled 0, and 3 minus 3 0 into anything will be 0, only c is remaining. Let me write that only, right? Now 3 minus 1, c into 3 minus 1 into 3 minus 2. So which will become 3 3s are 9 minus 1 is equal to 3 minus 1, c into 3 minus 1 is 2. 3 minus 2 is 1. So therefore, 9 minus 1 is 8 is equal to 2c. Otherwise, 2 1s are, 2 4s are you are going to get, which implies c is equal to 4. Okay. So therefore, you are getting now c is equal to 4 there. Here, you are having b is equal to minus 5. Now, I want to get the a value. A value, if I want to get it as means, I have to substitute here x is equals to 1. If I substitute x is equals to 1, then only b and c will get cancelled. Now, putting x is equals to 1. Put x is equals to 1. If you put x is equals to 1, in the left hand side, 3 into 1. 3 into 1 minus 1 is equal to, in the right hand side you are going to get it as c. B and c will get cancelled because 1 minus 1 is 0, 1 minus 1 is 0. Now you are having 1 minus 2 into 1 minus 3. So let me write that one, a into 1 minus 2 into 1 minus 3. I hope you understood this one. Now you can have, which will be remaining, 3 into 1 is 3 minus 1 is equal to 1 minus 2 is nothing but minus 1. 1 minus 3 is nothing but minus 2. Minus 2 into minus 1, which is plus 2. So a into minus 1 into minus 2, which will become 3 minus 1 is 2, which will be 2a. Otherwise 2 will get cancelled, a will be is equal to 1. Now you got all the values. A is 1, b is minus 5 and c is 4. So therefore substituting here, integral of 3x minus 1 divided by x minus 1 into x minus 2 into x minus 3 into dx, you can have integral of a divided by x minus 1 into dx plus integral of b divided by x minus 2 into dx plus integral of c divided by x minus 3 into dx. Substituting the a, b, c value and taking outside the integral because they are constant. A is 1, so 1 divided by x minus 1. I am neglecting 1 here, since 1 into anything will be the same thing. Now b value I got minus 5, plus into minus is minus 5 into 1 divided by x minus 2 into dx. Again, c value I have got it is plus 4. So plus 4 into integral of 1 divided by x minus 3 into dx. Now you can integrate this aram se, which will become log of modulus of x minus 1 divided by 1 minus 5 into log of modulus of x minus 2 divided by 1, because coefficient of x is 1 there, plus 4 into log of modulus of x minus 3 plus c. So, and this is your final answer. You are going to get it as dear students. I hope you understood this one. If you want, you can have minus symbol is there. You can take log of x minus 2 to the power of 5. Now here log of x minus 3 to the power of 4. You can have log m minus log n. Here log m into log n. Okay. So that is your final answer. You are going to get it as ds. Now we'll be moving on to the next problem. Integrate x divided by x minus 1 into x minus 2 into x minus 3 into dx. Same as you can have x divided by x minus 1 into x minus 2 into x minus 3, which can be written as denominator degree is greater than numerator a divided by x minus 1 plus b divided by x minus 2 plus c divided by x minus 3. Now here multiplication of throughout, here x will be written a into x minus 1 will go x minus 2 into x minus 3 is remaining plus b into x minus 2 will go x minus 1 into x minus 3 is remaining plus c into x minus 3 will go x minus 1 into x minus 2 is remaining, correct? Multiplying throughout that. Now what you are going to do? Put x equal to 2. If you put x equal to 2, a and c will get cancelled because 2 minus 2 is 0. Again 2 minus 2 is 0. A and c will get cancelled. Remaining is b only. So put x is equal to 2. 2 will be is equal to this will become 0 and c term will become 0. B is remaining b into 2 minus 1 into 2 minus 3. So which will become b into 2 minus 1 is 1, 2 minus 3 is minus 1. So therefore you are having minus b equal to 2 or b is equal to minus 2. Now you got b value is minus 2. Now going back to the step. Now put x equal to minus 2, a and c will get cancelled. Put x equal to 3. If you put x equal to 3, 3 minus 3, a will get cancelled. 3 minus 3, b will get cancelled. C is remaining. So now put x is equal to, put x is equals to 3. If you put x is equal to 3, left hand side 3 will be is equal to a and b will get cancelled. C only remaining, c into 3 minus 1 into 3 minus 2. So which will become 3 is equal to 3 minus 1 is 2. 3 minus 2 is 1. 2 into c, which is c will be is equal to 3 divided by 2. Now positive of 3 by 2. Now what you are going to do? Next, put x is equal to what value? I want to get cancelled with the b and c. Now if you put x is, see, x minus 1 is common. If you put x is equal to 1, 1 minus 1 is 0, 1 minus 1 is 0, b and c will get cancelled. Remaining is only a. Now put x is equals to plus 1. So left hand side is 1 because you are going to have it as x value is 1. Now b and c will get cancelled. Remaining is a into 1 minus 2. Putting x value 1 into 1 minus 3, which will become 1 is equal to a into 1 minus 2 is minus 1, 1 minus 3 is minus 2, minus 2 into minus 1 is plus 2, plus 2 into a is equal to 1 or a is equal to 1 by 2. Minus 1 into minus 2 is plus 2, plus 2 into a is equal to 1, a is equal to 1 by 2. Now substituting a value 1 by 2, b value as minus 2, c value as 3 by 2 in the given and integrating, which will become integral of x divided by x minus 1 into x minus 2 into x minus 3 into dx, which implies integral of a divided by x minus 1 into dx plus integral of b divided by x minus 2 into dx plus integral of c divided by x minus 3 into dx. So here substituting a value and taking out a value, are getting 1 by 2. 1 by 2 into integral of 1 divided by x minus 1 into dx plus b value is nothing but minus 2, plus into minus is minus 2 into integral of 1 divided by x minus 2 into dx. Again c value you are getting it as 3 by 2. So plus 3 by 2 will be outside. Integral of 1 by x minus 3 into dx. Now you can integrate this aram se, which is 1 by 2 into, which implies log of modulus of x minus 1 divided by coefficient of x is 1 minus 2 into log of modulus of x minus 2 plus 3 by 2 into log of modulus of x minus 3 divided by 1 plus c. And this is your final answer. You are going to get it as dear students. I hope you understood all these steps, how to solve the problems based on a partial fraction and how to reduce the improper partial fraction to a partial fractions. In the next class, we'll be solving some more problems related to this partial fractions. Keep watching. Have a nice day, dears.